The end of lithium. Elon Musk reveals new battery that will change the entire industry. The global demand for electric vehicles represents a pivotal point in the current transformation of the automotive industry. As environmental awareness grows and efforts to reduce greenhouse gas emissions intensify, the search for sustainable transportation alternatives is gaining momentum around the world. The emphasis on the transition to electric vehicles is evidenced by the industry's significant investment in advanced battery technology. In order to meet this growing global demand, manufacturers are focusing their efforts on developing more efficient, durable, and affordable batteries. Concern about battery life has been a barrier to the mass adoption of electric vehicles. However, recent scientific and technological advances offer exciting prospects. Scientists have achieved remarkable feats, extending the lifespan of batteries to up to 200 years. This not only reassures buyers concerned about longevity, but also opens the door to a paradigm shift in the way we view the durability of electric vehicles. Tesla, in particular, has played a prominent role in this narrative. The company initially expressed its intention to produce long-lasting batteries, promising 1 million miles of battery life. While initial enthusiasm was tempered, the recent presentation of positive test results indicating an ability to withstand 10,000 cycles and provide power for more than 2 million miles reignites optimism surrounding this technology. In addition to innovations in lithium-ion batteries, other approaches are also being explored. Lithium-sulfur, for example, is emerging as a more affordable and abundant alternative, potentially revolutionizing energy storage. The research and development of solid-state batteries, such as those made of aluminum and graphene, and those made of aluminum and sulfur, also show promises of greater efficiency, lower cost, and lower environmental impact. These advances not only shape the future of electric vehicles, but also have broader implications. The integration of durable batteries opens the door to innovative practices such as the vehicle-to-grid (V2G) concept, enabling cars to store and share energy with the electrical grid. The emphasis on battery longevity represents a key milestone in the evolution of the electric vehicle industry. As demand for sustainable mobility increases, the ability to significantly extend battery life becomes a strategic priority for manufacturers. Concern about battery durability has historically been one of the main obstacles to the mass adoption of electric vehicles. Consumers naturally want the assurance that their investment in an electric vehicle will be accompanied by a battery that maintains its performance over the years. In this context, recent advances in extending the useful life of batteries to up to 200 years represent a significant watershed. The long-term operation of electric vehicles intrinsically depends on the durability of the batteries. The ability to extend battery life not only alleviates consumer concerns, but also contributes to environmental sustainability by reducing frequent battery disposal and its impact on the environment. 2 years ago, the idea of a lithium-ion battery capable of lasting 1 million miles emerged, promising exceptional longevity and the ability to power electric vehicles for decades. However, the most recent advances go beyond this mark, reaching the incredible projection of 200 years of useful life. This achievement not only resets expectations for battery durability, but also represents a significant step forward toward broader adoption of electric vehicles. Tesla, as a leading innovator in the industry, initially expressed its intention to produce batteries that could last 1 million miles. While initial enthusiasm has been tempered, recent test results indicating that the batteries can withstand 10,000 cycles and provide power for more than 2 million miles revive confidence in the ability to produce truly durable batteries. These advances not only affect the automotive industry, but also have implications for broader industries. The possibility of extending the durability of batteries to 200 years suggests the feasibility of applications in stationary energy storage devices, opening the door to innovative practices such as the vehicle-to-grid (V2G) concept, where vehicles not only store energy for their own use, but also share it with the electrical grid. Advances in lithium-ion batteries are shaping the landscape of electric mobility, consolidating itself as a fundamental part of the technological revolution in the automotive industry. As demand for electric vehicles continues to grow, improving the efficiency and durability of lithium-ion batteries has become a strategic focus for researchers and manufacturers. Battery durability has always been a crucial consideration for electric vehicle consumers. 2 years ago, the idea of a 1 million-mile lithium-ion battery emerged as a promise of exceptional longevity. Since then, the industry has made remarkable progress, going beyond that milestone and recently reaching the impressive projection of 200 years of useful life. The test results presented by Tesla are particularly notable, indicating that the batteries can withstand 10,000 cycles and provide power for more than 2 million miles. These advancements not only reassure consumers about durability, but also signal the capability of a broader transition to long-lasting electric vehicles. These advances were achieved through the strategic combination of materials and technologies. The introduction of an artificial graphite anode, together with the use of a nickel-manganese cobalt battery, NMC532, proved to be an effective formula. Special additives, including a liquid separator between the electrodes, not only enable fast charging, but also contribute to battery life. A careful approach to cell treatment, avoiding full charge cycles from 0 to 100%, has been shown to be crucial to extending battery life. Performance graphs show greater consistency above 10,000 cycles, especially when charging from 0 to 80% or 0 to 90%, common practices among electric vehicle drivers. Tesla, for example, offers a minimum guarantee of retaining 70% battery capacity for 8 years or 120,000 miles, with suggestions that additional care can extend this durability to up to 15,000 cycles. These advances not only redefine expectations for lithium-ion batteries in electric vehicles, but also have broader implications. The possibility of extending the durability of batteries to 200 years paves the way for applications in stationary energy storage devices and innovative practices such as the vehicle-to-grid (V2G) concept, where vehicles not only consume energy but also the share with the electrical grid. Tesla's ongoing upgrades have been one of the most notable points in the evolution of the automotive industry, marking an innovative, customer-centric approach to electric vehicle development. Founded by visionary Elon Musk, Tesla has stood out not only for its high-performance electric cars, but also for its ability to improve them through regular software updates. The company has taken a unique approach, treating its vehicles more like constantly evolving technological gadgets than simple transportation machines. This car-as-a-service mentality has allowed Tesla to implement improvements and new features remotely, without the need for frequent dealership visits. Tesla's updates cover a variety of areas, from performance and range improvements to new safety and entertainment features. One notable example is the company's ability to improve vehicle autonomy through software updates, providing owners with a constantly optimized driving experience. Recently, Tesla introduced significant updates to its battery cells, highlighting advances that indicate impressive durability. Test results revealed the battery's ability to withstand 10,000 cycles and provide power for more than 2 million miles, representing a considerable leap forward from previous expectations. These advances in battery technology, combined with Tesla's commitment to providing regular updates, fuel consumer confidence in the durability and long-term performance of their electric vehicles. The company also offers robust warranties, such as retaining a minimum of 70% battery capacity for 8 years or 120,000 miles, providing additional assurance to owners. Furthermore, updates are not limited to just the vehicle's hardware. Tesla frequently introduces new software features, such as autonomous driving improvements, new driving modes and advanced entertainment features. This not only keeps vehicles up to date with the latest innovations, but also adds ongoing value to the user experience. The search for technologies that promote durability has become a central aspect in several industries, being particularly relevant in the constantly evolving scenario of electric vehicles and their batteries. Durability not only ensures the longevity of products, but also contributes to sustainability by reducing frequent disposal and environmental impacts. In the context of electric vehicles, battery technology has been a crucial area of innovation. Recently, notable advances in lithium-ion battery cells are redefining expectations. The introduction of an artificial graphite anode, combined with nickel-manganese cobalt batteries, NMC532, and the use of special additives, has allowed the creation of highly durable batteries. These innovations not only extend the life of batteries, but also open the door to producing electric vehicles with impressive durability. Recent test results indicate that these batteries can withstand 10,000 cycles and provide power for more than 2 million miles, representing a remarkable achievement in developing technologies for durability. Additionally, implementing smart practices in daily use also plays a significant role in preserving battery life. Avoiding full charge cycles from 0 to 100%, charging from 0 to 80% or 0 to 90%, and avoiding discharges below 25% to 50% capacity are practices that have proven effective in maintaining cell consistency and longevity. Other promising technologies that target durability include exploring alternative materials. Lithium-sulfur, for example, is emerging as a cheaper and more abundant option for battery storage, offering higher energy density and greater capacity retention after fast charging cycles. Furthermore, emerging technologies such as solid-state batteries, using aluminum ion and graphene, offer prospects of 3 times greater durability and charging capacity up to 70 times faster than traditional lithium-ion batteries. These technologies not only offer better performance, but also reduce dependence on rare elements, contributing to the sustainability and efficiency of electric vehicles. The integration of durable batteries is becoming a key player in the evolution of the electric vehicle sector, promoting not only the long-term reliability of vehicles but also opening the door to innovative applications in energy storage. The search for solutions that significantly extend battery life not only meets consumer expectations, but also drives sustainability by reducing the need for frequent replacement and disposal. Recently, notable advances have been made in the durability of lithium-ion batteries, with test results indicating the ability to withstand 10,000 cycles and provide power for more than 2 million miles. These advances not only reassure consumers about the longevity of their electric vehicles, but also lay the foundation for broader integration of these batteries into diverse applications. The integration of durable batteries goes beyond electric vehicles and extends to stationary energy storage devices. The ability of batteries to withstand thousands of charge and discharge cycles makes them ideal for storing renewable energy and thus addressing the challenges of intermittency associated with sources such as sun and wind. This practice, known as vehicle-to-grid (V2G), suggests a future where electric vehicles not only consume energy but also share it with the electrical grid, contributing to grid stability and efficiency. Tesla, a pioneer in this field, expressed interest in incorporating durable batteries into its models, highlighting its commitment to leveraging these technologies beyond conventional vehicles. This vision is shared by other companies, such as BID and CATL, which are also advancing the production of durable batteries with a useful life of up to 1 million miles. Furthermore, the integration of durable batteries can directly impact electrical infrastructure, promoting recycling practices and reducing dependence on non-renewable energy sources. Emerging technologies such as lithium-sulfur batteries or graphene aluminum-ion batteries offer not only greater durability but also additional benefits such as greater energy density and recyclability. In the near future, the integration of durable batteries will not just be limited to electric vehicles, but will be a central part of sustainable energy ecosystems. Collaboration between energy companies, automakers and governments will be essential to lay the foundation for a successful transition to the comprehensive integration of these technologies. Innovations in solid-state batteries are sparking a new era in energy storage technology, promising to overcome the limitations of traditional lithium-ion batteries and revolutionize the electric vehicle, electronics and storage systems industry in general. Unlike conventional batteries, which use liquid electrolytes, solid-state batteries employ solid materials as ion conductors. This fundamental change in battery architecture offers a number of notable benefits, starting with safety. Without flammable liquids, the risk of overheating and short-circuiting is significantly reduced, providing a safer solution for energy storage applications. Durability is also a strong point of solid-state batteries. By eliminating liquid materials susceptible to degradation over time, these batteries demonstrate greater resistance to wear, allowing a greater number of charge and discharge cycles without compromising performance. This is particularly relevant in the context of electric vehicles, where battery longevity is a primary concern. The speed of reloading is another highlighted advantage. Solid-state batteries have the potential to offer significantly faster recharge times than current lithium-ion batteries. This increase in charging efficiency will not only reduce waiting times for users, but also contribute to the viability and widespread acceptance of electric vehicles. Energy density is a crucial aspect of battery design, and innovations in solid-state batteries promise substantial advances in this regard. By using more efficient materials, these batteries have the potential to offer greater energy density, enabling extended-range electric vehicles and more energy-efficient electronic devices. It is worth noting that, despite promising prospects, solid-state batteries are still in the early stages of development and face significant technical challenges. The complexity of large-scale production, the selection of suitable materials and the maintenance of operational stability are areas that require continued attention. Innovative companies such as Tesla, Ford, and Mercedes-Benz are actively exploring solid-state battery technologies in collaboration with battery manufacturers, signaling a future potential for integrating this technology into mass-production vehicles. The quest for more efficient and durable batteries continues to drive innovation, and solid-state batteries represent an exciting chapter in this trajectory of technological advances. Aluminum and sulfur batteries emerge as a promising frontier in the evolution of energy storage technologies. This battery type offers revolutionary potential, overcoming some of the limitations associated with traditional lithium-ion batteries and introducing innovative features that could transform the energy storage landscape. The main advantage of aluminum-sulfur batteries lies in their significantly higher energy density compared to lithium-ion batteries. This means that these batteries have the ability to store more energy in a smaller space, allowing greater autonomy for electric vehicles and electronic devices. Another strong point is the potentially lower production cost. Aluminum is a widely available and more affordable material compared to elements used in lithium-ion batteries, such as cobalt. This characteristic can contribute to reducing manufacturing costs, making aluminum and sulfur batteries a more economically viable alternative. Furthermore, the aluminum-sulfur battery is known for its sustainable nature. Sulfur is an abundant element that is less harmful to the environment when compared to the materials used in some conventional batteries. This, combined with the ability to efficiently recycle aluminum, contributes to a more positive environmental footprint. Another important aspect is the speed of recharging. Aluminum-sulfur batteries have the potential to offer shorter recharge times than lithium-ion batteries, improving convenience for users and eliminating one of the perceived challenges in electric vehicles: waiting time for recharging. However, it is worth mentioning that aluminum and sulfur batteries are still in the research and development phase. Challenges such as operational stability and durability in real-world conditions need to be overcome for this technology to reach its full potential. Companies and research institutions are investing significantly in this field, recognizing the promising characteristics of aluminum and sulfur batteries. While the path to mass production and commercialization may take time, the potential of these batteries to transform the energy storage landscape is cause for great optimism. The constant advancement in energy storage technologies, particularly innovations related to long-life batteries, is having a significant impact on several industries. This impact ranges from electric vehicle manufacturing to the renewable energy sector, with notable implications for supply chains and business models. In the automotive sector, improvements in battery durability have direct repercussions. The ability to create batteries that withstand millions of miles of use not only increases consumer confidence in electric vehicles, but also redefines battery maintenance and replacement expectations. This has the potential to significantly impact the ownership costs of electric vehicles, making them more competitive against traditional fossil fuel vehicles. Furthermore, the integration of durable batteries opens doors to innovative applications such as the vehicle-to-grid (V2G) concept, where electric vehicles not only consume energy but can also return it to the electrical grid. This dynamic creates opportunities for closer interaction between the automotive industry and utility companies, transforming electric mobility into an active component in the management of the electrical grid. In the field of renewable energy, durable batteries have the potential to revolutionize the way we store and use energy generated by sources such as solar and wind. The ability to withstand thousands of charge and discharge cycles without significant degradation allows for more efficient and reliable use of these intermittent sources. The idea of storing excess energy for later use, or even to feed the electrical grid at times of high demand, becomes more tangible with durable batteries. Industries related to battery production are also experiencing significant changes. The search for more sustainable materials such as lithium-sulfur and the development of solid-state and aluminum-sulfur batteries present challenges and opportunities for battery manufacturers. Competition for more efficient and environmentally friendly technologies is driving innovation in this sector. Furthermore, the impact on industries extends beyond the energy and mobility sector. The development of more durable and efficient batteries could have implications for electronic devices, home energy storage systems and even aviation, providing a general push for the adoption of more sustainable solutions. The impact of innovations in energy storage technologies on industries is a transformative phenomenon that reverberates across sectors, redefining paradigms and shaping the future of business operations. From advances in long-lasting batteries to new approaches in energy storage, the impact is palpable on multiple fronts. In the automotive landscape, the evolution of batteries has been a catalyst for the growing acceptance of electric vehicles. Improved battery durability not only increases consumer confidence, but also redefines the vehicle life cycle, directly impacting maintenance strategies and associated costs. This, in turn, is driving the transition to more sustainable mobility, with the potential to transform automotive supply chains and related services infrastructure. In the energy sector, innovations in energy storage have a profound impact on renewables. The ability to efficiently store energy generated by intermittent sources such as solar and wind is crucial to ensuring a stable supply. Durable batteries offer practical solutions to smooth variations in energy production, facilitating the transition to a greener and self-sustainable energy matrix. The battery manufacturing industries are undergoing a revolution as demand for more efficient and sustainable solutions drives research and development. Competition for more affordable and environmentally friendly materials is resulting in advances in battery production, not just for electric vehicles, but also for electronic devices and home storage systems. The integration of durable batteries in sectors such as electronics and aviation is reshaping how these industries approach energy efficiency and sustainability. The ability to store more energy in smaller spaces and support extended charge and discharge cycles is opening up possibilities for innovations in electronic devices and more efficient air propulsion systems. Furthermore, the impact on industries extends into the sphere of decentralized renewable energy, where communities and businesses can become more self-sufficient, storing excess energy for future use or even contributing to the local electrical grid. In summary, the impact on industries is multifaceted, promoting a revolution in business models and encouraging a shift towards more sustainable practices. As innovations in energy storage continue to unfold, the industrial landscape is adapting to a new energy reality, leveraging not only economic but also environmental benefits. This is an exciting chapter in the journey towards a greener and more resilient economy. The prospects for a sustainable future gain strength as significant advances in energy storage technologies, electric mobility, and renewable sources shape a more promising scenario for the planet. In this optimistic horizon, we envision an accelerated transition towards more sustainable practices, driven by innovations that resonate across different areas. Sustainable mobility, powered by the development of durable batteries, is one of the fundamental pillars of this future. The growing adoption of electric vehicles will not only reduce carbon emissions associated with transportation, but will also transform the way we design cities and road infrastructure. The idea of public and private transport networks powered by clean energy sources becomes a tangible reality, contributing to the reduction of air pollution and improving the quality of urban life. Additionally, innovations in energy storage have the potential to democratize access to electricity in remote and developing regions. Efficient storage systems combined with renewable sources can offer sustainable energy solutions outside of traditional grids, empowering communities and driving economic development. The sustainable future is also on the horizons of industries. Growing demand for more efficient and environmentally friendly batteries is encouraging research and investment in innovative technologies. As solid-state batteries, aluminum-sulfur batteries, and other alternatives advance, the energy storage industry is preparing for a new chapter, driven by more durable, efficient, and sustainable solutions. The prospect of a sustainable future extends to the renewable energy landscape, where solar and wind stand out as dominant sources. The ability to efficiently store energy generated by these intermittent sources solves one of the fundamental challenges of the transition to a cleaner energy matrix. The decentralization of energy production, combined with advances in storage technologies, promises more resilient electrical grids that are less dependent on fossil fuels. Sustainability awareness is also shaping consumer decisions and corporate practices. Companies are increasingly committing to environmentally responsible practices, and consumers are valuing products and services aligned with sustainable principles. This movement drives innovation and the creation of more transparent and environmentally friendly supply chains. However, it is crucial to highlight that the path to a sustainable future is not without challenges. Issues such as the infrastructure needed to support large-scale electric mobility, the efficient management of technological waste and the just transition to greener economies are aspects that will require continued attention. In short, the prospects for a sustainable future are promising, with the convergence of technological innovations, changes in industrial practices, and a growing global awareness. This is a crucial time to drive sustainability in all spheres of society, building a positive legacy for future generations. If you like this type of content and want to receive more videos like this, subscribe to the channel here and stay tuned for the next videos. See you next time.